So we are starting lesson 4 today, and it's called Literal Equations and Formulas. And we're going to see that there is a difference. Literal equations are going to have numbers and variables still, but we're going to be solving in terms of a particular variable. I'll explain that more when we get there. Your assignment is posted in Schoology, and it's 1.4. And remember, we always take 2 days, so this is not due until September 13th, again at 11:59. We're going to want to start in page 13 of our notes. So, this picture right here, Nora drew a non-square rectangle. Then she drew the length of each side from end to end to make a line segment to represent the perimeter. So remember, perimeter is where you add all sides. So we're going to write an equation in order to do that. So it doesn't matter what you use. You can just go right around and go width plus length plus width plus length. So the perimeter is width plus length plus width plus length. This is a cursive L. I use that so you don't mistake it for a 1. Now, so that's one way we could do it. Now B says rearrange the order so you can represent the perimeter with a different equation. So I could rearrange these and put my L's together and put my W's together. So I could have W plus L plus L. Well, then you look at it and go, well, look at that. I could combine like terms. So perimeter is 2W plus 2L. That is the official formula for perimeter. I never memorize it because it's just as fast to just add all the sides. Now, the other thing we can do with that is we could rearrange it if we wanted to, and that's what literal equations are all about. And what we're saying there is, let's say that we want to solve for L. We want to get L by itself. We would start moving all this other stuff off. And what we realize is we won't have a number for these letters right here, but we treat them like they are numbers. And so we just kind of move around and how we do that. And that's what we're going to be learning about today. We already did this as much as possible. It has some cool things if you want to go into the interactive book. So we're going to put this on page 14 in example 1. Use your left-hand column to do this. Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. What equation can she use? So she wants to calculate time. Okay, that's important. It's also important that we need to know what is the simple interest formula. You don't need to have it memorized. Oh my gosh, no. But think about it. In the world that we live in right now, couldn't we just Google this? Yes. So interest is equal to principal times rate times time. So what we're saying is that Janet wants to know how much time does it take to earn a certain amount of interest. Okay, and the whole reason for literal equations is that if we want to do an activity many times, then we're going to solve for a particular variable. And this is used all the time in science. If I want to talk about a rate, so I'm in a science class, I can do a lab, I can figure out the distance, I can figure out the time, and then if I want to find the rate. And so if I'm going to do something over and over again, literal equations are awesome. Okay, so it's looking like Janet wants to figure out the time, and she maybe wants to do it and try different times in it. So we're going to get that t all by itself. So what we need to realize then is we're like, well, how are p and r connected to t? Hopefully you said multiplication, and you would be right. Oh, before we go any further, I should indicate what these all stand for. And so I is the interest, the simple interest, not compound. P is the principal, and the principal is what you invest, how much money you put in. R is the rate, and this is like so much money per year or whatever time. And T is time. And usually we're going to say years, but it can be months, weeks, it can be lots of different things. Okay, so now that we know that, we want to get rid of P and R. How are they connected? Multiplication, that's right. So what do? If I had an equation of 7 is equal to 3y, and I want to solve for y, how do I get rid of the 3? Right, you multiply. Okay, so that's what we're going to do over here. Sorry, I said that wrong. this is connected, the 3 and the y are connected by multiplication. If I want to get them apart, I would divide both sides by 3. So that's what we're going to do over here also. We're going to divide by PR. So then I just have I divided by PR is equal to T. So then, if I know my interest and I know my principal and I know my rate, I can just go in and find out how much time until I get a particular interest, okay? And we would know that interest. So that's what we're doing as far as the literal equations, is we're going to solve for a particular variable in terms of all the other variables. Good. This one is in your book on that same page where we were, and it says, what equation can Janet use to calculate the principal amount? So again, we're using I is equal to PRT. You do not have to memorize this formula. I'll give you any formulas that we're going to be manipulating to be literal equations, so don't worry about memorizing formulas. There's a couple that I'll suggest that you do, but this is not one of them. So now this time we want to get P by itself, and what I would recommend is put a box around the one that you are trying to isolate, the one that you're solving for. So we want to get P by itself. So now we look at this and we have to realize that we need to get rid of T and R. How are they connected? That's right, they're connected by multiplication. So what do? I divide both sides by RT. So I get I divided by RT is equal to P. Okay, you just want to isolate that one variable. Good. So this one is also in your book, and we are still on page 14. So Sarah is going to the store that is 2.5 miles away. She only has 15 minutes to get there before they close. At what average speed does she ride to get to the store before they close? Now this is a formula we've already used, I believe is in the last lesson, no, 2 lessons ago. Distance is equal to rate times time. Now this is a fairly common one, so this is one I would suggest you probably have in your head, and it's a very simple one and it's used quite a bit. Okay, so Sarah's going to the store that is 2.5 miles away. That is our distance. She only has 15 minutes to get there. That is our time to get there. At what average speed must she ride to get to the store before they close? So we want to find the average speed. Now, if we were in any other unit besides literal equations, we would just take and we would plug in all this information. We would have 2.5 is equal to rate times time, which is 15. And then we would just solve this equation. So we would divide both sides by 15. And we would get that the rate is equal to 2.5 divided by 15. Which is 0.166 ... Okay. Now, I've told you not to leave it as a repeating decimal, which I still agree with, but when we're talking in real world, we would have to do it. So this is 0.167. We would have to round. So we would say approximately. See these wavy equal signs? That means approximately. Okay, approximately, oh, don't forget that 0. Approximately miles per minute. So approximately 0.167 miles per minute. Miles per minute. And I know that because that's what I have right here. I would use that. Okay, not really useful. You might go back to the 2.5 over 15. You can reduce that. Oh, wow. Okay, so 2.5 divided by 15. If I'm going to reduce something that has decimals in it, what I do is I move the decimal point one place over, so I have to move this one place over. So that's 25 over 150. I then divide them both by 25, so I get 1 over 6. So 1/6 miles per minute. So 0.167 is not real helpful, but 1/6. And I wanted you to see how, when I have a fraction, how do I reduce it? So move the decimal point, get rid of all the decimal points, and then reduce this fraction like you would reduce any fraction, dividing by their common term, their common number. Okay, so any other time this is what I'm going to be doing. But because I'm in the section about literal equations, I want to actually solve for the rate. I want to write a formula. And again, this is one that's used in physics a lot, that you want to do test with and figure out rate. And so you can actually figure out, put it on the car on the track and do it. So what we're going to do here is we want to get rid of the t. How are they connected? Multiplication, divide by t. So I get d over t is equal to r. So our steps for literal equations. Let's just take some time right now to write that down. And what we want to do is first is we want to indicate what variable, because you have many, you are solving for. And when I say indicate, put a box around it. So just like over here, I put a box around this. Okay? Then you want to actually just look at it and say, you want to identify how that variable is connected to the other variables. I'm just going to say others. And then you want to start taking it apart, just like you would solve an equation. How do I get everything off that side? So then go about, so then you want to go about undoing it. So how do I word that? So then start use operations, add, subtract, multiply, and divide, to get all that stuff off of that side. So use operations to isolate that variable. Use operations to isolate the variables. And we'll practice this. Okay. So, habits of the mind. How is solving equations with numbers the same as solving equations with only variables? You do the same operations. You do the same operations, but you don't get a number. You get an expression. Okay? And the expression, what I mean by expression, is just 2x plus 5y. That's an expression. It's not an equation. An equation has to have an equal sign. So this is just an expression. So this is very typical for what happens. They give us a formula, and we take that formula, and we're going to rewrite this formula in terms of h. That's going to be our variable. Okay, so here we go. We have a is equal to 1/2 base times height. And we indicate the variable. Here is our variable, h. That's what we want to get to by itself. So then we start looking, well, how are these things connected? How is 1/2 and b connected to h? Well, it's connected by multiplication, but we might want to get rid of that fraction first. So use what we know about clearing fractions. So how do I clear a fraction? I'm going to multiply by the common denominator. Here there's only 1, so I'm going to multiply by 2. Now this is all connected by multiplication, so that is all one term. So I'm going to multiply that by 2 and this by 2. If it's connected by multiplication, it is just one term. So when I do that, my 2 cancels, and over on this side, I get a b and an h. Don't feel like you have to do all of it at once, and I would recommend not doing it all at once. And on the left-hand side, I have 2a. Again, I'm going to indicate my variable so I know what am I getting by itself. And now, I'm going to get rid of the b. How is b connected to h? Hopefully you said multiplication. So we're going to divide to get them apart. So our final answer then is 2a over b is equal to h. That is our answer. Okay, that is our entire answer because we have it in terms of h, meaning that I'm going to have h on one side, everything else on the other side. Then the next step is find the height of the triangle when a is 18 and b is 9. Now I realize we could have plugged it into this original equation, but we want to get into the habit of how can I change this. This will come up lots of different places. One of them is in graphing that we'll see next unit, I believe. So we're going to now plug this information in. So we have a 2. We're going to plug in a, which is 18. We're going to plug in b, which is 9. And we're going to find out h. So we find out that a is equal to 2 times 18 is 36 divided by 9 is 4. So our height, when they ask for our height is for, what are we in inches? Now remember, I know this might have thrown some of you off. Area is always in inches squared, so don't worry about did we have to do anything with it. No, we did not. Now this problem is in your book, so go to page 16 in your book right now, and we're going to solve this one. So what this means is we're going to take this equation and we have to solve for x. Okay, so we can just start right away with that equation. We don't even have to rewrite it. So what we're going to do is we're going to indicate a variable. We want to get x by itself. So we're going to solve for x. So how is x connected to 12? It's connected by addition. So now I'm going to do the operation to get it off of there. I'm going to subtract 12 from both sides. Now this is what throws students off, is they're like, well, I can't take 12 away from y. You're right. So you just write it as y minus 12 is equal to x. And bam, you are done. That's all you do. Okay? Pause if you need to. Rewind if you need to. That one's done. Okay, so this time we're solving for m. We want to get m all by itself. Now this is one that we can approach two different ways, and I'm going to show you the two different ways because I want your mind to decide how you would approach it. So if I do it, oh gosh, we could actually do this about 3 different ways now that I think about it. So it depends again on what does your brain see. Okay, so you look to see which one would I want to start with first. So what I'm talking about here, okay, so first we're going to just look at this one, isolate the variable. And I'm also going to draw a line to kind of show, and you're going to probably want to do that same thing. Okay, so for me, I would probably start off by saying, let's get rid of the fraction. Let's clear the fraction. Okay, but I want to tell you right now, you're going to see so much on this page. So this particular problem, I think we ended up doing 5 or 6 different ways. So there's lots of different ways you can approach this even as we get started. So just stay with me. Don't get overwhelmed. Just write down the notes as we do them. Okay, that's a scary warning to hear, isn't it? It's like, oh my gosh, what's coming? Don't worry, I got you. Okay, so what we're going to do is we're going to first clear the fraction. So remember, this is all one term because it's connected by multiplication right here. Because I have it right next to it, that's multiplication. So that is all one term, so I'm going to multiply this whole thing by 5. And when I do that, I get, and I'm going to put this over on this, I'm going to put 1 right here, 5n is equal to 4 times m plus 7. And I also get 5n is equal to 4 times m plus 7. Yes, I wrote the same thing twice because from here you can do it 2 different ways. So one way you can do it from here is that you can start going distributive property. Okay, whoops, always indicate the variable. Okay, so I could just distribute and I get 4m plus 28 is equal to 5n. And so I'm going to do a squiggly, kind of a squiggly line here because I'm going to do these 2 different ways. So now I'm going to do one at a time. This is an m. That's what we're going for, is that m right there. So now I can see that they are connected. I want to get the m by itself, so I have to get rid of the 28. So I'm going to subtract 28 from both sides. So I get 5n minus 28 is equal to 4m. Okay, now the 4 is connected to the m by multiplication, so I'm going to divide to get them apart. I'm going to divide, and I can divide the whole thing if I want to. And if I do that, okay, now it splits again. I can divide the whole thing by 4, and I get 4n minus 28 all over 5n minus 28 all over 4 is equal to m. That's one way I could write it. The other way I could have done this, I'm going to go back for just a second here. I have 5n minus 28 over 4 equals m. Well, let me just simplify from here. So, hold on. So I get this. Now, what I can do from here is this is one answer already. This is an answer. I have m isolated, so I am done. But the other thing I could do with that, just to let you know, is you can break this fraction into two parts. So I could have 5n over 4 minus 28 over 4 is equal to m. Then I reduce the fraction, so I have 5n over 4 minus 7 equals m. Okay? So that's one way I could do that. Now, let's go back up to the top. I could have, at this point right up here, I could have also done it another way. So I indicate the variable I'm going for. Well, you see that 4 is connected by multiplication. So I could right now divide both sides by 4. Okay? And then I'm going to get 5n over 4 is equal to m plus 7. Okay, so on the first side, I distributed. On the second one, I got rid of the 4, okay, by dividing. So again, I'm solving for m, so now I need to get rid of the 7. Again, you cannot combine those. Those are not like terms, so it's just 5n over 4 minus 7 is equal to m. And you might be saying, well, which way is the right way? That's just it. They all are. So it just depends on what your brain sees. And on this one, you just have to start and try different things. Okay? So on this next method, what I'm going to start off by doing after I indicate the variable is I'm going to actually distribute. Because a lot of times that's what our brain sees first. So I'm just going to distribute the 4/5 out. Now, I will give you one clue. If you're going to have a fraction here, don't simplify this, just multiply the numerators. 4 times 7 is 28. Okay? Indicate my variable I'm going for, never lose sight of that. But now, look, I have fractions. I'm going to get rid of fractions. So I'm going to multiply every single term by 5. Clear those fractions out. And I get 5n is equal to 4m, because my 5's canceled. See, my 5's divided to 1, okay? And I get 4m plus my 5's cancel, so I have 28, okay? What am I solving for? M. Hopefully I haven't lost you. Stay with me. If you need to pause your video and take a break, because this is a lot for your brain, do that, okay? Now I'm solving for m, so I'm going to get rid of the 28. 5n minus 28 is equal to 4m. Okay, let me stop for just a second and reassure you, you're never going to have to do it 20 million ways. What I'm trying to do is I'm trying to give your brain different paths on how you could see starting this. All of these are right. Okay, so keep that in mind. All of these are right. You're only going to choose one of them, but I want to show you all the options. Okay, now here again, what I can do is that I can split this. So either, and I'm going to write it out twice, so just pause for a second. So I'm going to isolate this variable. Whoops, so I'm just going to move it. Hold on. So I'm trying to isolate this variable, but it is not wanting me to do that. So I'm going to indicate that is m is what I'm trying to get by itself. So here again, I have two options. So that's the reason I wrote it out twice. If you want to pause and rewrite yours so you have it written out twice. One way I can do it from here is that I can divide the whole thing by 4. And that's what we did over here on this side, which is great. Okay. The other option is, and that one's done. Yay, there's an answer. Okay. The other option that I really want you to be aware of, because it's going to show up in graphing, is that we can divide every single term by 4. Divide every single term by 4. Both sides do this. So this side and this side I'm still dividing by 4, I can just show it 2 different ways. Here I divided the whole thing. Here I divided each individual term. Okay, so I get 5n over 4 minus 7 is equal to m. Notice my answers. Do they look familiar? Have I seen them? Yes, I have. Okay, so you're going, no, not one more. Yes, there is one more. Now, those of you who are into speed, you're going to go, oh, why didn't you just show us this one? Because it's not where our brain usually goes. So before I show you this method, I just want to refresh your memory. If I would have had something that's 2/3 x is equal to 12, we were taught, I know you were in 7th grade math, that in order to get rid of a fraction, if a fraction is connected by multiplication, I can just multiply by its reciprocal. Because when I do that, my 3's cancel, my 2's cancel, and I just have x. Okay, and then you can just multiply over here. But I can multiply by the reciprocal. And that's the third method I'm going to show you now. Okay, so I can isolate the variable, indicate the variable, and I'm going to now multiply both sides because, remember, this whole side is one term because it's connected by multiplication. So I'm going to multiply by 5/4. When I do that on the right-hand side, I just have 5/4 n. And on the left-hand side, notice everything that can cancel. I can divide the 5's and get a 1. I can divide the 4's out and get a 1. So then what I am left with is m plus 7. Okay, so I'm just down to that. And that is a very quick way to do it. And so that's the reason into speed, or if as you get into higher math classes, your professors might be doing that. So now I want to get rid of the 7. I just subtract both sides by 7. So I get 5/4 n minus 7 is equal to m. Oh my gosh, look at that page. That is just a whole bunch of stuff. Hope you got it. If not, maybe pause and go back over it. We're going to be practicing some more, so don't worry about it too much, okay? And I'm going to stop the video right here because that's just a lot. I'll have a part 2 coming up.